A newfound solar system just 39 light-years away contains 7 warm, rocky planets, scientists say. That discovery, reported Wednesday in the journal Nature, represents the first time astronomers have detected so many terrestrial planets orbiting a single star. Researchers say the system is an ideal laboratory for studying distant worlds and could be the best place in the galaxy to search for life beyond Earth. Before this, if you wanted to study terrestrial planets, we had only 4 of them and they were all in our solar system, said lead author Michael Gillen, an exoplanet researcher at the University of Liege in Belgium. Now we have 7 Earth-sized planets to expand our understanding. Yes, we have the possibility to find water and life. But even if we don't, whatever we find will be super interesting. The newly discovered solar system resembles a scaled-down version of our own. The star at its center, an ultra-cool dwarf called TRAPPIST-1, is less than a tenth the size of our Sun and about a quarter as warm. Its planets circle tightly around it, the closest takes just a day and a half to complete an orbit and the most distant takes about 20 days. If these planets orbited a larger, brighter star they would be fried to a crisp. But TRAPPIST-1 is so cool that all 7 of the bodies are bathed in just the right amount of warmth to hold liquid water. And 3 of them receive the same amount of heat as Venus, Earth and Mars, putting them in the habitable zone, that Goldilocks region where it's thought life can thrive. The researchers call these worlds Earthlike, though it's a generous term. The planets of the TRAPPIST-1 system do resemble Earth in terms of size, mass and the energy they receive from their star. But there's a lot that makes our planet livable besides being a warm rock. Further observation is required to determine the composition of the TRAPPIST-1 bodies, if they have atmospheres and if they hold water, methane, oxygen and carbon dioxide, the molecules that scientists consider biosignatures, or signs of life. You can bet people will be rushing to take those measurements, said Elizabeth Adams, an exoplanet researcher at the Planetary Science Institute who was not involved in the study. That's going to be fascinating to see. Whatever secrets it may harbor, the TRAPPIST-1 system would surely be a sight to behold. Though the star is small, its nearness to the planets means that, from their perspective, it appears about 3 times as large as our Sun. The outermost planets enjoy the daily spectacle of their neighbors passing across the sky and in front of their shared Sun, each world a large dark spot silhouetted against the salmon-colored star. Its dim glow, which skews toward the red and infrared end of the light spectrum, bathes the planets in warmth and paints their skies with the crimson hues of a perpetual sunset. Gillen and his colleagues have been interested in TRAPPIST-1 since late 2015. Using the European Southern Observatory's Transiting Planets and Planetesimal Small Telescope, TRAPPIST, in Chile, they sensed small dips in the star's brightness at regular intervals. These dips were caused by planets transiting, crossing between the star and Earth and blocking some of its light. Last May, the scientists published their discovery in Nature: 3 rocky bodies, dubbed TRAPPIST-1b, 1c and 1d, orbited a small star, they said. But right around the time the study was published, Gillen noticed that TRAPPIST-1d was behaving oddly. When he went to get a closer look with the Very Large Telescope, the ESO's gigantic observatory in South America's Atacama Desert, he realized that the dip in brightness he thought came from 1d was actually caused by 3 planets, all transiting at the same time. This happens only once every 3 years, said Julian DeWitt, a planetary scientist at the Massachusetts Institute of Technology and a co-author on the study. The chance of catching it is less than 1 in 1,000, he explained. It's funny because it's such a huge paper with amazing results, and we got it from sheer luck. Next, the team hurried to request time at the Spitzer Space Telescope, whose Earth-trailing orbit around the Sun offered an uninterrupted view of TRAPPIST-1 and its companions. During 20 days with the Spitzer telescope, the team witnessed 34 transits. These observations lifted the veil on the architecture of the system, as DeWitt put it. Instead of 3 planets, TRAPPIST-1 had 7, renamed TRAPPIST-1b through H in order of their distance from the star. The scientists determined that the 6 inner planets are locked in an orbital resonance, meaning that the lengths of their orbits are related by ratio of whole numbers. Because of this, the bodies exert irregular gravitational influences on one another. By measuring those influences, the astronomers could determine the mass of the planets, something that is impossible to figure out from transiting data alone. That in turn allowed them to loosely calculate their densities, giving a sense of how much iron, rock, water and gas the bodies contain. The fact the planets are in orbital resonance also suggests that they formed farther out from their sun and then migrated inward, Gillen said. This makes it more likely that they will contain water in some form, since water and other volatile compounds, molecules that readily turn to gas, tend to concentrate on the outer edges of solar systems. Coincidentally, TRAPPIST-1 is in the constellation Aquarius, the water bearer. For years, evidence has accumulated that the Milky Way galaxy is full of Earth-like planets. That discovery of 7 such worlds around a single, faint star suggests that they may be even more common than originally thought. Gillen and his colleagues plan to seek out similar solar systems with a new project, Search for Habitable Planets Eclipsing Ultra-Cool Stars, or Speculoos. Like Trappist beer, Speculoos cookies are a Belgian delicacy. His next effort will have to be called waffles. Meanwhile, scientists are scrambling to get a better look at Proxima b, a rocky world that was discovered orbiting our Sun's nearest neighbor, Proxima Centauri, last August. But the TRAPPIST-1 researchers, along with several astronomers not involved with the study, say this system is our best target yet to search for extraterrestrial life. Though exoplanet scientists often focus on worlds orbiting sun-like stars, the brightness of those stars makes it difficult to spot small, rocky planets. TRAPPIST-1's planets are easy to find amid its dim, cool glow. The system is also incredibly close to Earth. Though 39 light-years would be a long way for humans to travel, it's practically next door when you consider that the Milky Way galaxy alone is 100,000 light-years across. The closeness of TRAPPIST-1 puts it within the reach of the James Webb Space Telescope, which will be able to detect atmospheric components and thermal emissions from the planets after it launches in 2018. In the meantime, telescopes on several continents have been trained on the system to search for signs of life. Last summer, the scientists published an early analysis of the atmospheres of planets B and C using data from the Hubble Space Telescope. This is direct exploration of another solar system that is happening right now, Gillen said. Planets C, F and G are the most intriguing targets for astrobiologists because of their position in TRAPPIST-1's habitable zone. But even if they turn out to be warm and wet, these worlds might not be great places to live. The planets' proximity to the star and one another means that they are probably tidally locked, like Earth's moon. One side of each planet always faces the sun, the other is stuck in constant darkness. This would make for a dramatic temperature gradient that could generate powerful winds, not exactly an Earthling's idea of a cozy home. And Adams, of the Planetary Science Institute, cautioned that it's very hard to tell whether a planet is habitable from a distance. An observer outside our solar system might look at Venus, Earth and Mars and reason that the Sun hosts 3 habitable worlds. The alien would need to travel here in person to discover that Venus is a cloudy hellscape with a runaway greenhouse effect, while Mars is a barren, frozen desert with a defunct internal dynamo. There are a lot of ways in which a planet could be like Earth, but not enough, Adams said. Another major caveat, she added, is that the very idea of a habitable world is purely theoretical. Scientists have only one source of data on habitable planets, and that's Earth. We don't actually know the parameters that are needed for life on another world, Adams said, how much it has to look exactly like Earth and how different life could be elsewhere. Still, even if no life is discovered on them, the TRAPPIST-1 planets present an unprecedented new window on how solar systems work. Though the planets are more or less Earth-size, their varying densities and distances allow for detailed comparisons of the worlds. It's almost as if someone designed an experiment in planet formation, controlling for the body's size. DeWitt compared the new planets to 7 new languages, each offering a new vocabulary for describing its corner of the universe. They all have a slightly different perspective and the same story, he said, the story of this solar system.